welcome back, guys. We're at 4.3, day 1, properties of logs. We're going to expand log expressions and simplify the result when possible. Okay, and first of all, we got to recall that evaluating logarithmic expressions, well, some log expressions are equal to a nice, aka rational number. Okay, for instance, log base 2 is 64. Okay, maybe it's not a super obvious one, but if you play around with it a little while, you'll figure out eventually that 2 to the 6th power equals 64. So that means this is equal to 6. And again, it's as I said, because 2 to the 6th equals 64. Okay, now our next one, we've got log of 10,000. Well, that's going to be equal to 4, and maybe it's, again, not obvious, but remember there's a little subscript of 10 in there. And again, this is equal to 4, and it's because if we take 10 to the 4th, we get that 10,000. Got it right there, a little bit small, but anyway, there it is. Okay, now our last one, natural log of e to the 5th. Okay, again, imagine that the subscript that's kind of squeezed in there, that little subscript e, or the base of the log being e. And then again, you're saying, hey, e to what power is the same thing as e to the 5th? Well, pretty much obviously, that's got to be a 5, because e to the 5th is e to the 5th. All right, so anyway, some of them simplify very nicely is the point of all that messing around. Okay, and of course, other logarithmic expressions are not something that equals something nice, like log base 5 of 37. Okay, I don't know about you, but I sure can't think of 5 to some power that works out to be 37. All right, same thing as the next one. There's an implied 10 for log base 10 of 20, or the common log of 20. But yeah, I can't think of taking 10 to a power and landing on 20. If you're thinking 2, okay, that's multiplying, that doesn't count. You need to be able to raise 10 to some kind of power and land on 20, and yeah, the only way to pull it off is something pretty nasty and messy decimal-wise. Same thing at the end there with natural log of 16. E to what power 16? I don't know, but it's definitely not nice. So some are nice, some are not. That's the point of that whole slide. Let's move on. All right, so expanding logs here. Okay, there are times when the expression inside of a log is fairly messy, but there are some rules or properties, depending on what part of the book you look at, of logs that allow us to break single logs into multiple logs of less messy expressions. Ultimately, we're going to get down to logs of single numbers or single letters, but we'll get to that as we go. All right, now first of all, we've got the product rule here. Okay, so if you let b, m, and n be positive real numbers, we see there, and I'm not going to say b the whole time, log of m times n, we claim is equal to log of m plus log of n. All right, so as it says below that, the log of a product is the sum of the logs. All right, cool. So let's demonstrate that because, again, anybody can say anything. Let's give at least a little bit of proof here. All right, we already know that log base 2 of 64 is 6 from earlier in the lesson. That was the first one that I simplified on the first slide. Okay, we also know that 64 could be written as 4 times 16. Okay, so if I've got log base 2 of 64 on the left side, well, of course, that equals 6. We already know that. Okay, now log base 2 of 4 times 16. If we use that property up there, so I've got this multiplication, and apparently I can turn it into addition of two separate logs. And so what that means is we would get log base 2 of 4, then plus log base 2 of 16 at this point. All right. Well, let's see, log base 2 of 4. I think I can raise 2 to a power and get 4, and yeah, I sure can. That works out to be 2. And let's see, log base 2 of 16. Can I raise 2 to a power and land on 16? I sure can. That's 4. All right, so basically, notice here we get 6 equals 2 plus 4, and I'm pretty sure that's good. So happy faces all around, at least for this example. It seems like that rule holds true. All right. So the log of a product can be turned into the sum of two logs. However, what if there is a division or a quotient inside of a log? Well, we've got the quotient rule for that. So same thing if we've got b, m, and n are all numbers. Okay, it seems like based on our rule, the log of some kind of a quotient or as a division is equal to log minus log. But notice it is log of the top minus log of the bottom. That is critical, the order, because you're subtracting. But anyway, so at the bottom it says the log of a quotient is the difference of the logs. All right, cool. So we can turn a quotient inside of a log into log minus log. All right, now again, we can claim anything we like, but let's back it up. Okay, to demonstrate, we're going to use the fact that 64 is the same thing as 128 divided by 2. All right, now again, log base 2 is 64. We've very much established that's 6. All right, cool. All right, now again, our property seems to say that if we have a division, we can turn that into a subtraction. Now, of course, I wrote the division as a divide by sign instead of a fraction, just because it was quite honestly easier using the program I was using to do that. But anyway, here we go. So I got log base 2 of 128 minus log base 2 of 2. All right, So I still got my 6 on the left. Let's work out the right. Okay, now log base 2 of 128. Okay, without a long explanation of that, that does work out to be 7, and if you don't believe me, please take 2 to the 7th power, see what you get. I promise it'll be 128. So basically that first half becomes a 7, then I got a minus sign, and log base 2 of 2. Well, if I raise 2 to the first power, I sure get 2. So that means that expression equals 1, and I'm left with 6 equals 7 minus 1. And again, I'm pretty sure that is a true statement. So again, a little bit of verification that that quotient rule is true. All right, moving on. Okay, lastly, it's fairly common to find expressions involving exponents inside of logarithms. Okay, fortunately, we've got a rule for that called the power rule. Okay, if b and m are positive numbers, again, same basic setup as before, but we've also got now p, okay, and p is any real number we want it to be. All right, let me zoom in. Oh, this is a little harder to see. Okay, but we're claiming log base b of m to the p power. Okay, notice we have kind of like 3 different levels of stuff. We have subscripts, regular stuff, and then exponents going on here, so be careful so you're sure what you're looking at. Okay, now basically what happens between the left side of our equation and the right side, that p that we've got as an exponent kind of jumps down in front of the log and lands right there. So it becomes a coefficient if it was an exponent inside the log. Okay, the book gives some kind of a very wordy version of that right there. I'm not going to bother reading it, but let's demonstrate. We're going to still go with what we've been using, but we're going to say that, hey, 64, that's the same thing as 4 to the third. Okay, so I've rewritten things that way. And again, log base 2 is 64, that sucker is 6. Okay, now again, our property seems to claim, and let's change colors here a little bit, that that 3 can get ripped off of being an exponent and then kind of plop down in front of the log. Okay, so what that looks like then is 3 times log base 2 of 4. All right, so again, my left side's just chilling out being a 6, and I've got 3 times, well, let's see, log base 2 of 4. If I raise 2 to the 2nd power, I get 4, so yeah, that equals 2, and yep, 6 equals 3 times 2. I'm pretty sure that's good. Okay, again, just a little verification that this rule here actually makes a little bit of sense. All right, so here we go. The assignment will involve using possibly all 3 of those properties in a single problem. Okay, and therefore it's important to decide at each step which rule or property best applies to the situation. So just ask yourself at each step if the expression inside the log is overall a product, a quotient, or a power, and once you identify which one it is, then of course that's the rule you use. Okay, excuse me. Additionally, don't forget to simplify any expression that works out to be a rational, non-messy decimal, such as log base 3 of 81, okay, which of course equals 4 because 3 to the 4th is 81. All right, so if you'd like things in one spot, here's all 3 of those. Now again, the book calls them properties now instead of rules, but it does write rule off to the side on the right. So again, they're kind of dodgy with exactly what they're calling these things, properties or rules, but there it is. All right, so all 3 of those guys all together, and they've numbered them 1, 2, and 3. I'm going to refer to 1, 2, and 3 as I go through this. So the first one is that product rule. A product inside a log becomes a sum of 2 logs. A quotient rule number 2. A quotient becomes a subtraction of 2 logs. And then the third one is that power rule, where you can rip an exponent off and kind of stick it in front as a coefficient. All right, so here's what your assignment's going to look like, give or take a little bit. All right, so here we go. First one, we got log base 8 of x to the 2nd, y to the 7th. Okay, now, obviously not a quotient because there's no division there anywhere. Okay, so the question is this a power or is this a product? Okay, now you do see exponents, but the 2 and the 7, both the exponents we have, neither of them applies to the global the expression, like all of it all at once. The 7 only applies to the y, the x only has a 2 on it, or for the square. Okay, so this is definitely a product. So at this point, we've got property 1. Okay, so our product rule. Okay, so since it's a product, that means I can break it into log plus log. Okay, now the base never changes through this whole mess, so it's log base 8 still, and then we've got x to the 2nd, I've got plus log base 8 of y to the 7th. Okay, so there's that, and now each of those we can look at and say, okay, which property applies, if any, at this point? And log base 8 of x to the 2nd, and same thing with the other one, they both have exponents on them. Okay, so that's our power rule, so that's property 3 in each case. All right, so we can go ahead and do that, and if we apply that property, we get 2 times log base 8 of x plus 7 times log base 8 of y. Okay, and I kind of alluded to this earlier, but let me say it a little more sternly now. Okay, we have now gone to the point where we have a single letter x and a single letter y inside of each log, so that's as far as you can go. Okay, now certainly those are letters, so there's nothing we can simplify further. If the x or y were numbers, we could talk about maybe simplifying things if they were some kind of power of 8. But again, as variables, we definitely don't have that option, so that's as far as we can go with this. Bam, so that's what your answers are going to look like for today. All right, moving on to our next one here. Okay, now this one's a little bit messy, so I did put those helper lines, although I probably could have used them on the last one as well. But anyway, at least just to get us started. Okay, now this one, again, we definitely have some exponents, we definitely have some multiplication, the 16 times x to the 6th, and we definitely have some division. But overall, if you're going to tag this as one of those things, it's got to be as a quotient. So basically what we're starting with here is property number 2. All right, so it's a division, so let's break it into log minus log. All right, so again, just to separate all of our subscripts and exponents, we've got log subscript 4, and then we've got ourselves a 16x to the 6th. All right, and then we're going to have a minus sign because we're doing a quotient, and then it's log base 4 y to the 5th. Okay, as I'm writing that, I was feeling a little bit silly about that. Hopefully you're like, yeah, we got it. But anyway, just being very clear, the 4s are subscripts, everything else is on the line except for the 6 and the 5 being exponents. Okay, but moving on from here. Okay, if we look at their first of the two terms, okay, here I have a 16 and an x to the 6th inside a log, and those are connected with multiplication. And again, there is an exponent, but that exponent only applies to the x and not to the 16. So this definitely is a product. So this is now property number 1 that we can work with. However, the other guy on the right, okay, there's only a y inside the log, and it does have an exponent on it, but what that means is that this guy is basically property number 3, our power rule. So we're going to rip that 5 and throw it in front of that guy, although the first half of the problem, we've got that property 1, so we're going to rip it apart into log plus log. All right, so brace for impact, here this comes. Okay, so we've got log base 4 of 16 plus log base 4 of x to the 6th is what our first half becomes, and then again, minus that 5 comes out in front, times log base 4 of y. Okay, now that last term is now a single letter inside the log, so basically he's done. Okay, looking at the first half, all right. Okay, I've got log base 4 of 16. Okay, that is a number, so you need to ask yourself, hey, is that something I can simplify, or is it something I should leave alone? Well, certainly 4 to the 2nd would be 16, so definitely turn that guy into a 2. All right, plus. Okay, now here I've got property number 3 working again. I didn't leave myself enough room to write it. But anyway, there's property 3, so that 6 can get ripped off of the x and thrown in front of the log. So that becomes 6 times log base 4 of x. Okay, and again, as I said earlier, that last term was kind of already done. So 5 times log base 4 of y comes on down, and that would be our final answer there. Okay, please resist the temptation to add the 2 and the 6 together, get an 8, because the 2 is just a regular number and the 6 has that log attached to it, so they're not like terms. Don't do anything with them. All right, a few more to go here. Let's move on. Okay, next one here, I've got natural log of e to the 5th over the cube root of x. All right, well again, if I'm looking at this thing as either a product, a quotient, or some kind of a power, okay, that's definitely a quotient because any powers I see only apply to individual bits and not a global sort of thing. All right, so again, this is basically a property 2 situation from the start. All right, so we're going to turn this into log minus log. So natural log e to the 5th minus natural log of the cube root of x. All right, so now we move on to looking at these individually and seeing if there's something we can do with them. All right, okay, now natural log of e to the 5th, well, wait a minute, the subscript for the natural log is an e, or the base of the natural log is an e. That means that's an expression I can simplify, and if you remember, that's 1 from the beginning of our lesson, and because the natural log of e to the 5th works out, well, sorry, it works out to be 5, because again, you're asking yourself, e to what power is the same thing as e to the 5th? Well, that's got to be the 5th power. So that guy just simplifies down to a 5. Okay, now I actually have a fair amount of messing around here on the second half. Okay, I don't have a root rule, but I do have a power rule. But remember, roots and powers are interchangeable if you can turn a root into a fractional power, which of course you can if you care to. And in this case, it's a good idea too, because if you don't, you're not going to get the answer you're supposed to. All right, so anyway, basically what we get here is natural log. Okay, now the third root is the same thing as a 1/3 power. Okay, but the second we do that, hey, we've got that property number 3 again, that exponent rule. So that exponent gets ripped off and thrown in front. And so what that gives us here is 5 minus 1/3 times the natural log of x. And I got to be careful before I intrude in the next problem space. But anyway, there you are. Again, if you're thinking going, ooh, what's 5 minus a third? You don't care because the third has a natural log x attached to it and the 5 doesn't. So they're not like terms. Don't touch them. All right. Moving on to our next one here. Okay. Whoops. Got somebody peeking off the bottom there. Don't want that. All right. Log root x plus 5 over 1,000. Holy cow. Okay. Well, again, if I'm thinking this is either a quotient, product, or an exponent, I'm definitely thinking this guy's a quotient because anything that I see only applies to bits and pieces and not the whole thing globally, other than the fact that I have a fraction. Therefore, this is a quotient, and I want to go ahead and use property number 2. All right, so what that means for us here is I have the log of the top, x plus 5, minus the log of the bottom, which is a log of 1,000 now. Okay, now hopefully something is kind of screaming in your head that, hey, there's no subscript there. Oh, that's right, I know the subscript is a 10. Okay, so again, if it helps you, you can throw those 10s in there. It's certainly not necessary, but it's not one of those things I'd mark you wrong for. So if it does help you, put in those implied bases if it helps you process whatever's happening. Okay, I'm not going to keep writing them, but anyway, go for it if it works for you. All right, now first thing, I've got the log root x plus 5. So just like the last problem, if I've got a root, I can rewrite that as a fractional exponent. So this could be log of x plus 5 to the 1/2 power. All right, and moving along the other side, let's see, log base 10 of 1,000. Wait a minute, I think 1,000 is a power of 10. Yeah, it sure is, and if I take 10 to the third, I get myself 1,000. Okay, powers of 10 are really easy. You basically count how many zeros you got, and that's what power of 10 you have. So basically, that last part turns into a 3, and I just need to work with the first part. All right, now again, the whole reason of turning the root into a power is that it gives us property 3. All right, so that 1/2 gets ripped off and thrown in front. So it's 1/2 times the log of x plus 5 minus 3. Okay, now in case you're thinking, hey, let's distribute the log, well, the log is not something that distributes. Okay, it's a function that we're using, and it's not a distributable thing. Okay, now notice those rules we had. We don't have a sum rule. Okay, there is nothing that works if you have log of something plus something else. You can't go any further with it. Stop there, and we are, in this case, are done. Okay, I don't want to do it within the video, but if you want me to kind of show you a few examples of how that would be bad, I will be happy to do that in class. But moral of the story is don't like distribute log because it's not something that does that. All right, last problem here. Boom. Okay, and as it's the last one, it's the messiest one, but anyway, here we go. Okay, log base 3 of the 5th root of 7x to the 4th over y to the 2nd. Lots of stuff happening here. Okay, now the first thing I would do is say, wait a minute. Okay, that's the 5th root. I don't like roots. I like exponents better when I'm dealing with logs. So first thing I'm going to do is turn this into log base 3 of, big old fraction, 7x to the 4th over y to the 2nd, and I'm going to put that all to the 1/5 power. Okay, now here we do have some choices about how we go forward. We could simplify that expression by applying the 1/5 power to everything inside the parentheses, giving us some fractional exponents, 7 to the 1/5, x to the 4/5, and y to the 2/5, so that would be one option. That is not the option I'm going to go with here as my explanation. If you want to see me do that, I'll do it in class. But anyway, here's the way I would handle it. Although, again, this is just my opinion and not necessarily a better way than the other. I would take the 1/5 and bring it in front, and I forgot to write it there, but basically what we have now is property number 3, where we're ripping that exponent off and putting it in front. All right, so now we have 1/5 times log base 3 of that fraction that no longer needs parentheses around it. All right, okay, so now that 1/5 is kind of a coefficient of the entire thing, so the bad news is everything we do from this point is going to have kind of a 1/5 in front of it, or the way I'm going to handle it, and I need to make a little space, is I'm going to do 1/5 and then open up a parenthesis and then let everything else that happens happen, and then we'll kind of distribute the 1/5 at the end. Okay, but looking at the mess we have right now, okay, this is definitely property 2 because we have a quotient. All right, so this becomes log base 3 of the numerator, 7x to the 4th, minus log base 3, that's a 3 I swear, of the denominator, y squared. All right. Now, again, we do have some messing around we can definitely do inside our big parentheses right now. First of all, log base 3 of 7x to the 4th, well, hey, that's property number 1 now, because we definitely have a product. Okay, the log base 3 of y to the 2nd, well, that's property number 3 because we've got ourselves a power. All right, and it is a global power for that one. Again, there was a power in the first half, but that fourth power was only on the x and not on the 7, so we were kind of stuck. All right, so a little bit of cleanup now gets me a 1/5 parenthesis log base 3 of 7, and I swear that's a 3. All right, and then plus log base 3 of x to the 4th, and then our last term becomes 2 times log base 3 of y. All right, getting close. Let's keep going, although I'm running low on room here. Okay, so looking at the 3 terms we have inside the parenthesis, okay, all right, that 4 is the only thing we can really do anything with because it's the power of the entire thing inside the log right there. So this is definitely a property 3 sort of situation. All right, and I think I'll save us a little bit of time here. I'm going to imagine that 4 is already in front, and because that's the only thing I can do, I'm going to now distribute that 1/5. And if I distribute that 1/5, I get myself a 1/5 times log base 3 of 7. Okay, I didn't say it, but hopefully you're looking at it going, yeah, I can't raise 3 to a power and get 7. So that's one that doesn't simplify. Okay, then, okay, the 4 jumps in front of the log, and then the 1/5 distributes, giving us a 4/5 times log base 3 of x. And then finally, that 1/5 distributes to the 2, giving us a 2/5. And then we've got our times log base 3 of y. Okay, again, notice that at the end here, every single log is a log of a single number or a single letter. And if we would have been able to simplify log base 3 of 7, we would have, but since we can't, we leave it alone. And then that mess right there is your final answer in that ultra messy situation that we've got there. All right, let me zoom out a little bit so the whole thing's on at once. But there you go. Okay, as always, I hope that all made sense. But if not, please ask in class for clarification. I'll be happy to explain anything further, and I will see you there.